In previous lectures, we learned what are double integral, surface integral, area integral, triple integral, volume integral. We obtained mass of a plane lamina, we obtained mass of a body, we obtained surface and volumes, and sometimes the integration is not directly easy in Cartesian coordinates. So we take some variable transformation. Sometimes it happens from the Cartesian to cylindrical polar coordinate. Sometimes it happens from Cartesian to spherical polar coordinate. And sometimes we take Cartesian to another Cartesian or orthogonal coordinates. So let us take some examples to see how we take substitution of variables to integrate. So first problem, let us take, it is very simple problem. Find the area of the circle x square plus y square is equal to a square. So just take a circle. This is a circle, and you can see that I have taken the elementary very representative circle. Its origin, center is origin. So this 0 0, this is the center, and the radius, this radius is a. So we will find the area. We have already learned what is the formula for area. So area is equal to double integral dy dx. And what is y and what is x? So y and sorry, what is dy dx? So dy dx is elementary area, and we obtained several surface areas in the previous lectures. Here we will not directly put the limits of y and x. We will convert this into cylindrical polar coordinate. So let us take, let x is equal to r cos theta and y is equal to r sin theta. We have also learned through the Jacobians that this dx dy is equivalent to j x y r theta dr d theta, and this Jacobian is r, so this is r dr d theta. So now we replace this area formula by area is equal to this r dr d theta, and you can see that this is the circle. So r is radius varies from 0 to a, and theta is angle. So theta for the complete circle, it varies from 0 to 2 pi. So this 0 to 2 pi. Now this is integral with constant limits. So we have already seen in previous lectures that when limit is constant, we can independently integrate r and theta. So you can directly put r integral as r square by 2, and the limit is 0 to a, and d theta integral as theta, and limit is 0 to 2 pi. So you get a square by 2 into 2 pi, and that is pi a square, which is the standard area of this circle. You already know this. Let us now take the second problem. Find the mass of a plane lamina bounded by the circle x square plus y square is equal to a square, and given that density per unit area of the lamina is rho is equal to square root of a square minus x square minus y square. In previous lectures, we have already obtained the mass. So mass is equal to, this mass is equal to integral bounded by the region bounded by circle. This region R is the region bounded by the circle, means the disk, and rho dx dy. So this will be double integral rho is square root of a square minus x square minus y square dy dx. And what are the limits? So because this is the circle, x square plus y square is equal to a square, So a varies from minus a to a. Sorry, x varies from minus a to a. So x varies from minus a to a. Then y varies from minus square root of a square minus x square to plus square root in the upper half circle. So this is minus square root of a square minus x square, and this is plus square root of a square minus x square. We have already learned about these things also in the previous lectures, so I am not emphasizing more on how we are getting these limits. So this is the integral that we have obtained, and we have to simplify this. So let us first integrate the internal integral. Means take, let I is equal to minus square root of a square minus x square to plus square root of a square minus x square, and then square root of a square minus x square minus y square dy. So let a square minus x square is equal to alpha square, so that we have the integral of the form minus alpha to plus alpha square root of alpha square minus y square dy. And because y is even function, we can write it as 0 to 2 times 0 to alpha square root of alpha square minus y square dy. Now if we take y is equal to alpha sine theta, then we will get dy is equal to alpha cos theta d theta, and limit of theta will vary from 0 to pi by 2. So we will get I is equal to this I is equal to 2 times 0 to pi by 2, then square root of alpha square minus alpha square sine square theta. So alpha can be taken common, so alpha, and 1 minus sine square theta will become cos square theta. So alpha cos theta, and dy is already alpha cos theta d theta. So I is equal to 2 times 0 to pi by 2 alpha square cos square theta d theta, and we already know this formula: 0 to pi by 2 cos to the power p theta sine to the power q theta d theta is equal to gamma p plus 1 by 2 gamma q plus 1 by 2 by 2 times gamma p plus q plus 2 by 2. So we will use this formula here. So we get 2 alpha square gamma 2 plus 1 means 3 by 2 p plus 1 by 2, remember this, and sine is not here, so sine to the power 0, so gamma 1 by 2, then 2 times gamma 2 plus 3 plus 1 by 2. So this becomes 2 alpha square by 2, and gamma 3 by 2 is 1 by 2 root pi, gamma 1 by 2 is root pi, and divided by this is 3 plus 1 by 2, 3 plus 1 by 2 means 4 by 2 means gamma 2 means 1 factorial means 1. So we got alpha square pi by 2. Now because we took alpha square is equal to a square minus x square, so we have this I is equal to pi by 2 a square minus x square. This is our I, And now what is the mass? So mass is minus a to a I dx. So put this value of I here. So we have minus a to a pi by 2. And why did we take I as inner integral? So we have learned this also in the previous two lectures. So if you are not aware of this, go to the previous lectures and first learn why we took the inner integral as I. So this pi by 2 and a square minus x square dx. Now, because again this integrand is symmetric, it is even function of x, so we can take it 2 times 0 to a square minus x square dx. And I hope that you can integrate this easily. This first part a square will give you a square into x, so a cube, and this second part will give you x cube by 3, so a cube by 3, so a cube minus a cube by 3 means 2a cube by 3. So our answer is 2 pi a cube by 3. So this is 2 pi a cube by 3. This is the mass of the lamina required in the question. Now let us take this problem. Evaluate the integral, double integral x square plus y square plus 2xy over the region bounded by the ellipse x square by a square plus y square by b square is equal to 1. So first draw an ellipse. If this is the ellipse and this is major axis, this is x-axis and this is y-axis, so the formula of ellipse is x square by a square plus y square by b square is equal to 1. So we will get the values of y as plus minus b times square root of 1 minus x square by a square. The negative part will lie in the lower half and the positive part will lie in the upper half. So this is the limit of y, and limit of x varies from minus a to plus a. We have already learned a lot about putting the limits, so you can, if you are not able to grasp this one, you can go to any previous lecture and learn about the putting limit. So the integral, let us say this integral I, let I is equal to the double integral x square plus y square plus 2xy dx dy, and where r is this region bounded by the ellipse, so we need to put the limits. So the limits are minus a to a and minus plus minus b square root of 1 minus x square by a square, and then b square root of 1 minus x square by a square, and this integrand x square plus y square plus 2xy dx dy. So for the sake of writing easiness, let us take the lower limit as this, as plus minus bx, means upper limit as capital Bx, this as capital Bx, and then obviously this is minus bx, means b square root of 1 minus x square by a square, we will take it as bx just for the sake of writing easiness. So we get minus a to a minus bx to bx x square plus y square plus 2xy dx dy. And we know that variable limit stands for y, so we will integrate y first, and because the third term y is in first power means odd function, so minus b to b y, this will become 0, so this is summarily 0. So the integral that remains, you know that if fx is some odd function, then minus a to a fx is equal to 0. So keep that in mind why I have taken the integral of last term equal to 0. So the integral that remains with us is minus a to a minus bx to bx x square plus y square dx dy. So let us first integrate the inner part. And what is the inner part? Let us take it I1. I1 is equal to minus bx to bx x square plus y square and integral with respect to y. This is inner part. So we will get x square y plus 1 by 3 y cube, and the limits are minus bx to plus bx, so we get x square, and again y and y cube both are odd functions, so if you put the limit at the first part, then b minus minus b is 2b, so this is twice bx, and same in the second part, here you will get minus b cube minus minus b cube means 2 times b cube, so this minus 1 by 3, this plus 1 by 3 bx whole cube. And if you write the value of bx again, so this becomes 2 times x square, and we took bx as b square root of 1 minus x square by a square. This was our b, and minus, sorry, plus 1 by 3, then b cube means b 1 minus x square by a square, this cube means 3 by 2. So this is our I1, and now we need to put this I1 to evaluate the complete integral. So I is equal to, this I was our minus a to a I1 dx, and I1 is this complete part, so you need to put this whole thing inside I1. So let us first put this. So we have 2b minus a to a x square square root of 1 minus x square by a square dx plus 1 by 3 b cube minus a to a 1 minus x square by a square whole power 3 by 2 dx. So this is our I1 now, and there is a little calculation mistake. This will also become 2, so this will become 2, and therefore this is 2 times. Now this is looking some hectic type integral, so we will take transformation. So what transformation? Let x is x square by a square, yeah, something, or let x by a is equal to sine theta. So we will take x by a is equal to sine theta. So x by a is equal to sine theta, and this gives in turn dx is equal to a cos theta d theta. And what are the limits? So limits of theta are minus pi by 2 to pi by 2. So because this all you can see x all the x's are in even power, so these are even functions, we can also take twice of the integral, and the limit will become 0 to pi by 2. So we will write this as I is equal to 4b 0 to pi by 2 a square sine square theta cos theta a cos theta, and I suggest you to put these transformation as your own work, so you will learn how to put this. Don't just watch the video and assume that everything is true. Sometimes the calculation in your video may be wrong, and and you will also not understand unless and otherwise you put everything actually. So this is then 4 by 3 b cube 0 to pi by 2 cos cube theta a cos theta d theta, and finally we have 4a cube b pi by 16 plus 4 by 3a b cube 3 pi by 16, which we can write as pi ab by 4 a square plus b square. Now you might be thinking why I have directly written these integrals in this form. So I am writing the clarification here, and this is also your homework. So for the first part 0 to pi by 2, I am not taking a square and a, this you can take common, so you will get a cube. So sine square theta cos square theta d theta, we just learned the formula for this in the previous question. So this is gamma 3 by 2 gamma 3 by 2 and 2 gamma 6 by 2. So you can evaluate this, and similarly the second integral 0 to pi by 2 cos cube cos to the power 4 theta cos to the power 4 theta d theta. So here power of sine is 0, so you can write is 0 to pi by 2 sine to the power 0 theta cos to the power 4 theta d theta, and this will be written as gamma 1 by 2 gamma 5 by 2 by 2 gamma 6 by 2. So this is how you evaluate and how I have written this directly. So you can evaluate this, and you must remember that gamma 1 by 2 is equal to square root of pi. Let us take the new question. Find the center of gravity of a plane lamina bounded by the lemniscate x by a to the power 2 by 3, y by b to the power 2 by 3 is equal to 1. X and y are non-negative. Density of the lamina is given by rho is equal to xy. So I think you must have learned the tracing of curves, and if you know that the shape of lamina is something like this, this. So this point is a comma 0, this is minus a comma 0, this is 0 comma b, and this is 0 comma minus b. But question instruct us that x and y are non-negative, means we have to consider the first quadrant only. So this area, this region we will consider, and we will disregard these three regions. So now let us first write the formula for center of gravity. You have already learned these things in the physics. So center of gravity x bar y bar, and that is calculated by x bar is calculated as x rho dx dy over the region and divided by rho dx dy. This is the formula for x bar, and formula for y bar is rho y dx dy divided by rho dx dy. This is the formula for center of gravity. So first we will be calculating the mass that appears in the denominator, then we will calculate the moment of mass that appears in the numerator. So let us start. let m be taken as the integral over the given region rho dx dy, so that it is double integral and rho is xy dx dy. What is the limit? So you can see in this region first quadrant, a varies from 0 to, sorry, x varies from 0 to a. And what is the limit of y? So y, I have already drawn this strip. You can see there is an strip, this is an strip. So the lower limit is 0 and upper limit comes from the curve. So lower limit of y is 0 and upper limit is b to the power p, then 1 minus x by a to the power 2 by 3 and the whole power 3 by 2. This is our limit, upper limit of y, and 0 is the lower limit. This simplifies to, you will integrate y integral first obviously. So this simplifies to 0 to a. You can separately take this integral as we have done in previous questions. So you can take inner integral as I or something, by name I1, I2, different, separately and integrate it. So I am integrating here. Y becomes y square by 2. So x into 1 by 2 and y square, and the limits are 0 to that one given here. This is the limit. So let us put this limit. So we get 1 by 2, 0 to a x. And what is the limit of y now? So I am writing here. Watch that this is the limit, b into 1 minus x by a to the power whole 2 by 3, then 3 by 2. So if you square this, you will get b square and 1 minus x by a to the power 2 by 3 and whole power 3, because there is a denominator in power, means 3 by 2 is the power. So this is our mass. Now we have to integrate it directly as a function of x. So we will take some substitutions here. So take this substitution. X is equal to a sine cube theta. This will give 1 minus x by a to the power 2 by 3 is equal to cos square theta, and dx will be 3a sine square theta cos theta d theta. Limit of theta will vary from 0 to pi by 2 and 0 pi by 2. So put the substitution in the given integral so that we have I is equal to b square by 2, 0 to a x 1 minus x by 2 to the power 2 by 3 and this whole cube dx as b square by 2, 0 to pi by 2 a cube a square sine to the power 5 theta cos to the power 7 theta d theta. Put this substitution and you will get this. This is not much easy, but just you have to collect the powers of sine theta and cos theta. So we have already used this formula in previous questions. So we get a square b square by 2, and uh, due to this dx 3 will be there, so this is 3b square. So 3a square b square by 2 and 0 to pi by 2. And why write again 0 to pi by 2? Just put the formula for this. We have already discussed the formula for this in previous question. So this will become gamma 5 sin has power 5, so 5 plus 1 by 2, 6 by 2 means 3, and then cos has power 7, so 7 plus 1, 8 by 2 means gamma 4, and then in the denominator gamma 7. This gamma 7, so you can evaluate these values of gamma by the formula gamma n is equal to n minus 1 factorial. You know already how to calculate factorial, so just put these values in place of gamma, so you will find the actual value of I. So now we will calculate the next part. Now we need to find this integral, double integral over the region x rho dx dy. So we will have everything same except that x is multiplied in the integrand. So we will put the limits similar, we will put everything similar. So we have 0 to a and 0 to, let me say this limit bx, and x rho is xy, you can see here. So this is x square y dx dy. Then you need to integrate with respect to y. So this is 0 to a x square bx square by 2 dx. And what is bx square? This is square of the upper limit, and from the previous part we know that upper limit was b times 1 minus x by a to the power 2 by 3 and whole power 3. So this is our bx. So we will take the same substitution as we adopted in the previous part, means x is equal to a sine cube theta. So we will get same everything similar that we have done in the previous part, except that this x square will be a square sine to the power 6 theta. Everything is same. In previous part it was x, so it was a sine cube theta. So now we replace all the things here, so we get the result of this as 1 by 2 b square, or 3 by 2 we receive 3 by 2 a cube, and 0 to, in previous part we obtained a square, here is a cube due to this x square. So this 0 to pi by 2 and sine to the power 8 theta cos to the power 7 theta d theta. And as per our formula for this integral, we will get 3 by 2 a cube b square, then gamma 9 by 2 gamma 7 by 2, this cos to the power 7 means 7 plus 1 by 2, 8 by 2 means 4, gamma 4, and then 2 gamma 7, 2 gamma 17 by 2. So now just what remain is that put these values in the formula of center of gravity. So center of gravity x coordinate was defined as double integral over the region x rho dx dy, sorry, this is dy, x rho dx dy, and then divided by double integral over the same region rho dx dy. So we have obtained the values for all of this in the terms of gamma function. So a numerator is 3 by 2 a cube b square gamma 9 by 2 gamma 4 by gamma 17 by 2, and this 2, this is numerator, and what is denominator? This was 3 by 2 a square b square gamma 3 gamma 4 by gamma 2 gamma 7. So just you need to evaluate these gamma and simplify. You can see that 3 by 2 is cancelled out, a cube as one part, a square that is cancelled out, b square is cancelled out. So these many parts will get cancelled out. So you will get a and something like gamma 9 by 2, gamma 4 is cancelled out, this gamma 9 by 2 and by 2 gamma 17 by 2, this in the numerator, and then 3 by 2 a square b square gamma 4 has cancelled, so gamma 3 and divided by 2 gamma 7 in the denominator. Just simplify this gamma by the formula gamma n is equal to n minus 1 factorial, and for the rational parts I am writing here. So gamma 9 by 2 is equal to 7 by 2, 5 by 2, 3 by 2, 1 by 2 root pi, and gamma 17 by 2 is equal to 13, 15 by 2, 13 by 2, 11 by 2, 9 by 2, gamma 9 by 2. You need not expand this because this will cancel out the gamma 9 by 2 in the numerator, and thus this is the first part, x coordinate of center of gravity. Remaining y coordinate, so this remains to you as a homework. To avoid the length of the video, I am stopping here, and you will find the y bar in similar way as I have calculated x bar.